Just a minute, I'll come back. Over just 2-3 minutes. Voice and display both are okay. Shall I start? Voice and display both are okay means I will start. I get good space here. Today camera I am able to set so that good space is there. Voice and display both are okay. Any problem? No, voice and display. If no problem, we will start. No reply still. See? Unless you reply, I can't start, because if there is any voice problem, then I will be wasting my time. Still no reply. Both okay? Both are okay. Okay, I will start now. See, this is the same master question. You can write here, same master question. Master question which we last class solved by slope deflection method. Today we will solve by moment distribution method. And remember, next class we will solve by Carney's method. And also we will complete BMD. And next class, because Carney's method will not take much time because FPMs are coming now. And one more thing, SFD BMD you know how to draw it. So I can give you some extra information in the concluding class. Okay. Now, I wrote the question once again. Okay. All data given here. This is a question. I told already you know it. You should go through last class. Analysis of continuous beams with support settlement. Of course, given support settlement. Very important. It is called given support settlement. Means settlement should be given in the question. There is one more case. See, for example, suppose a beam here, a support given like this. This is called elastic support. People sometimes call spring support. It is not spring actually. They call spring to understand for easy communication or telling each other. It is called elastic support. This also same thing. See, I told you support gets compressed. That much beam will sink. Here, the compression depends upon stiffness of the member. Here, how much it compresses, they are given in the question. Here, it is unknown. Therefore, here, delta is not given, delta is unknown. You require special provision for that one. Because additional unknown will come in the form of delta for that question. Okay, now, time being, leave it. Start moment distribution method. As usual. See, remember, as I told, this class is for my regular batch to whom this is continued. So everything I explained there, I will not repeat. Those who are newcomers, they understand whatever possible. For their sake, I cannot tell each and everything once again. So this class is meant for my regular group. But I am making public because those who are in the regular group, any day they can refer it. Others, those who got problem about this delta, etc., that they will understand. But some of the concept, yes, they should know it. Okay, start. Now, first remember, MD method or Kani's method. What you do? I told you, correct concept is told in the class. Remember, I never go for crude method. That is actually not correct. If I solve a question, I never do by crude method. But sometimes correct concept confusing. So some easy method, instead of crude method, some easy way of explaining. See, I told you, this is absolutely fixed. Absolutely fixed. This is intermediate by virtue of which it is called fixed. It is considered as fixed for stiffness and carryover, but this is absolutely fixed. C also intermediate, therefore considered as fixed. Now D is not intermediate support because overhangs should not be considered. So you cover the overhang. So D is a simple support. Remember, this is, I will put this way, red color. See. Now, if I fully round off, it will become simple support. That is when there is no continuation here. Then final moment equal to 0. But here, final moment is not 0. This moment and this moment will be equal and opposite. But moment is not unknown. It is still called simple support. So what I do is, if you remember, I write like this. Simple support rounding is there, partial round. So that moment is not 0, but still it is simple support. I write with overhang. Remember, all this concept I explained in the class, in the group, in my usual group. Clear? All this I explained in the usual group. Newcomers, they understand how much is possible. Okay, over. Now, remember, just to understand, see, at B, when you do stiffness calculation, at B, BA, far end is fixed. So BA equal to I by L. BC, far end is intermediate support. Therefore, this also equal to I by L. These all easy method. C, CB, far end is intermediate. So CB also becomes I by L. But CD, far end is simple support. Therefore, stiffness of CD will be red color, 3/4 of I by L. When you decide stiffness, should not see this support. You should see far end support. See, far end fixed, I by L. Far end intermediate. Intermediate considered as fixed, I by L. Far end intermediate, I by L. Far L simple support, therefore 3/4 of I by L. Those who are using actual stiffness, they should write, wherever I wrote I by L, they should write 4E I by L. Wherever I wrote 3/4 I by L, they should write 3E I by L. Both are same. Okay. Remember, this is not only for MD method, it's also for Kani's method. So tomorrow, when I do this by Kani's method, what I will do, I will tell now only. Or I will start by Kani's method today only. Safer side. Today only I start by Kani and stop. Okay, start. Calculation of distribution factor. Class. What all I tell in the class, you write. What you write is, this is moment distribution method. So you should write statement. Relative stiffness K equal to I by L when far end is fixed or intermediate support, or you should write I by L when far end is fixed, 3/4 I by L when far end is simple support. Then make a note, intermediate supports are considered as fixed for stiffness and carryover, and when far end is free end, stiffness equal to 0. This all I am telling earlier. Okay, then this is required. Now start. Joint B, BA I by L, BC also I by L, substitute, I by L, 1.8 I by 6, here 2 I by 5. Tell me fast, 1.8 by 6 plus 2 by 5. Answer. My calculator is not there. I don't have my calculator here, it is inside. I will bring it during the break. Answer. 1.8 I by 6 plus 2 by 5. Fast. Don't waste time. My calculator is not here. I will remove the mic and go and bring it. 7 I by 10. Don't give wrong values. 7 I by 10. Okay. Now tell me. Distribution factor. K by sigma K. 1.8 by 6 divided by 7 by 10. Tell the answer. 1.8 by 6 divided by 7 by 10. And 2 by 5 divided by 7 by 10. Tell the two answers fast. Distribution factor. Answer. 3 by 7 and 4 by 7. Okay. 3 by 7 and 4 by 7. Okay, done. I will check it now. 18, 1 minute, 1.8 by 6. R 3 R only. 3 by 10. That is 2 by 4 by 10. Perfectly correct. Okay. I got my own method. Okay, start. Come to C. Stiffness, relative stiffness of CB, I by L, 2 I by 5. This also is I by L, 2 I by 5. Stiffness of CD is 3/4 I by L. Remember, it is 3/4. 3 by 4 of I by L. Be careful. Equal to 3 by 4 of what? I by 4. Little this side. I by 4. Tell the answer. Total. 2 by 5 plus 3 by 4 of I by 4. Answer. 3 by 5, 2 by 5 plus 3 by 4 of I by 4. Total. I will do my own calculation. 2 by 5. 3 by. Okay, so my own calculation not required. 4 into 2, 6. 4 into 2, 8. This is 1.2. 1.2 correct? N2. 2 into 2, 0.6. 2 into 2, 4 by 5 is 1.6. That is 1. But 1 becomes 0.75. I require calculator. Answer. 23 I by 20. Okay, I will check later. Total 23 I by 20. Don't make mistake. Now tell me. Distribution factor. 2 by 5 divided by 23 by 20. Distribution factor. Actually, first of all, in for the group people, I am wasting time. This you already know. I am telling because there may be newcomers. Okay, at least let them get some benefit. At least let them get some benefit. 8 by 23, don't give wrong values. 8 by 23 and, I write here now, 8 by 23 and 13 by 23, correct? Other is 13 by 23, correct? 15 by 23, okay. 15 by 23. Or I can check it some other way. 2 into 2, 4. 0.8. 16 0.75. 0.75 is 1.5. 16 is 32. 16 Allah. This is 2 by 5 is 0.75. 4 into 2 is 4. Again 8 by 5 is 1.6. 3.2. It is 3 point. I am getting doubt. No, something wrong you have done. You have done something wrong. Not possible. Sorry, see. Now I have to go and get my calculator. If you make mistake like this, it is time waste. You should be careful for these things. I cannot make the mistake. It is surely wrong. I can make out. See, you are not careful. You wasted time. You have forced me to go inside, get my calculator. Because I can make out. I know directly distribution factor has got a link with the slope deflection method. Therefore, actually, since SD expressions are not there, I cannot tell. If the SD solution is still there, I can tell the answer by looking at SD method only. I can tell the answer by looking at SD method. See, the total is, how possible? Let me see, 2 by 5 plus 3 by 4 of 1 by 4 is 47 by 80 it is coming. It is coming 47 by 80. What you have done? 47 I by 80 it is coming. See there. It is coming 47 by 80. See there. What you have done? 2 by 5 plus 3 by 4 of 1 by 4. It is coming 47 by 80. Okay, now if you divide, it comes to 2 by 5 divided by 47 by 80 is, calculator. 2 by 5 divided by 47 by 80 is 32 by 47. Another one is 15 by 47. Now correct. See, I nearly, see there. I went to SD method. See there, what I got. See, I got. You see here, what I got. I went to SD method. You don't ask me what is going on. Someone will ask, sir, in SD method, 1.5 will not come. It will not come for you. For me, it will come. I got the tricks. See, I wrote here, see, 3215. 3.2, 1.5 is 3215. Yes or no? That's why I told your answer is wrong. Now clear? Clear now? See, I went to SD method, got the coefficient there. 1.5 will not come for everybody. For me, it will come. There's a trick there. Now see, then I told, you told something else. I told wrong. Okay, now correct. Okay, now correct. Please start. Now, this is for moment distribution method. Okay, now, at the end of the class, remind me, I will start Kani's method today only, because I do not want to waste the time of all these once again. Remind me. If I tell class is over, remind me to start Kani's method. Agreed? Sir, Kani, just remind me. So that I don't have to waste time tomorrow. I don't have to waste time tomorrow. Remind me, start Kani and leave it. Kani's method will do late tomorrow because SFD BFD is there. But I will tell you why later. Okay, start. See, today, master question we are solving by moment distribution method. Okay, start. Next step, calculation of FPMs, M bar, kilonewton meter. Now, what all I tell, write here. Agreed? What all I tell now, you write here. You should write. Agreed or not? Everything I am going to tell now, right now. Agreed. Okay, start. In slope deflection method, we use the equation mxy equal to m bar xy plus 2e into I by L into 2 theta x plus theta y plus or minus 3 delta by L. There, 2 ei by L and the 3 ei delta by L together becomes 6 EI delta by L square plus or minus. So in slope deflection method, this m bar xy is for loading, only for loading, only for loading. Tell me, this is the FPM due to what? Tell me. This is the FPM due to what? Tell me. Simple language. This is the FPM due to what? Simple language. That is the FPM due to. Due to what? This everything you have tried. Due to slope. Ayyo. 6 2EI by L into 3 delta by L becomes 6EI delta by L square due to slope. What is that? That is due to settlement, vertical displacement or delta. Correct? Remember 6EI delta by L square. Remember it? That is the FPM due to delta. Remember or not? Remember it? Or during derivation of SD method, I told you, see, consider the beam as fixed. Consider only loading. Let m bar xy, m bar yx be FPMs. Now, let the one of the support settle down or up or relatively perpendicular member by delta. For that, FPM is 6EI delta by L square. I told m double dash at that time. So therefore, in SD method, make a note, in slope deflection method, when you consider m bar xy, it is only due to what? Tell me. Only due to. In slope deflection method, the term m bar xy is only due to. Which one? Only due to. In slope deflection method, this all you are right. M bar xy is only due to. You are not answering. In slope deflection method, the term m bar xy, no, FPM correct. It is the FPM only due to what? It is the FPM only due to. Last time you have done it. It is everything is FPM only. Only due to loading. Because FPMs due to delta will come in the equation. Yes or no? FPM due to delta right here will come in the equation. Clear? It will come in the expression or equation, not equation. It will come in the expression. Yes, right. But, but in moment distribution method, but for moment distribution method and also for Carney's method, you write this way. Then tomorrow when you write for Carney's method, you write for Carney's method and also for moment distribution method. Today you write for moment distribution method. In the bracket write also for Carney's method. When you solve this by Carney's method, you write for Carney's method in the bracket also for MD method. Clear? Perfect grammar. Clear or not? For today, tomorrow, see, today is 18th. 19th is tomorrow. When you go to 19th, 18th becomes yesterday. Correct? See, now today 18th. So 18th is today, 19th is tomorrow. When you go tomorrow, if you tell 19th is today, 18th becomes yesterday. That way, right? For there is no equation. Therefore, I told you for MD method and also for Carney's method, when we find FPMs, symbol is M bar, consider what? Not only loads, but also, which one? Tell me. Simple language. Consider not only loads, but also simple language. Symbol will do. Don't waste time. Symbol. But also not only loads but also delta. Delta means that given support settlement. Clear? Therefore, when we calculate FPMs, M bar, kN meter in the bracket, right, considering what? Considering what? Loading, considering loading and also given support settlement. Given support settlements. Fully clear? So when you write FPM, you write here SD method, it comes in the equation or expression. For MD method and Kani's method, you write calculation of FPMs, symbol M bar in unit kilonewton meter, considering loading and also given support settlement. Fully clear? For MD and Kani. Fully clear? Okay, done. Now those not clear, go to recording 100 times. I don't know where I kept it. See, usual here. Go to recording 100 times. Over. Now, okay, this much over. Now what you do is, loading we can write here. Note you can write. I told write everything. It may become 2 pages. Write it. Write it for MD. Write it for Kani also. Okay, now, loading there is no problem. But when you want FPM due to support settlements, then numerical values of settlements are given. So you require numerical value of EI. You write here, you should write that one. You should write if you understand. You require numerical value of EI. Therefore, whenever the settlement is given, numerical values, they have to give numerical value of EI. But sometimes they can give settlement in terms of EI. Then EI will get cancelled. I will tell you next class. Okay, start. Now, given E, see the question, 200 GPa, I, 8000 centimeter power 4. We are solving the question or unit in basic unit, kilonewton and meter. Therefore, using this data, multiply with the proper unit conversion and get EI 16,000 kilonewton meter square. This I told you at last class only. This is your problem. If you cannot do this one, you are not fit to study structural engineering. E given, I given, unit separately given, convert to common unit and multiply, get EI in 16th. Actually, I explained earlier. Okay, over. EI over. Now, before that, you draw a sketch here that is given support settlements. Given support settlement, whatever they are given, you write there. See, as per the, I told you one more thing. See, A, B, C. This is A, this is B, this is C, this is D. Someone will tell, sir, O-rank is there. No. O-ranks are not considered for delta. Clear or not? Tell me. This I told you. O-ranks are not considered for anything. Only loading. This delta, I told delta, theta, geta, uta, dancing, sinking has no effect on the O-rank. Remember or not? I cried 100 times last time. Yes or no? For O-rank, never bother about those things. Tell me yes or no. I cannot keep on telling that way every class. I told when you consider O-rank, nothing, dancing, sinking, rising, nothing considered. See, given support settlement, supports are A, B, C, D. They told A rises by 8, B sinks by 14, C sinks by 4. And now, one thing. Do not write A, B, C, D here. Confusion will come. Therefore, I told you, what you do is A, mark here. B, mark here. C, mark here. D, mark here. Do not write name. You name the points after you mark delta. Some people write A and A dash. Then confusion will come. I have seen confusion. So better, do not use. See, now A is initially here, finally A is here. Final position you mark. Clear? This I told you. Mark the final position. No dash dash etc. Okay. Or now. This is over. Now start. First step. Consider one by one member. Consider A, B. See correctly A, B. See. A and B both are fixed ends. Why? When you find FPM, I told thousands of times. What? Whatever support given, consider fixed. One sketch you write for loading. 30 kilonewton per meter. Kilonewton per meter. Span you write here. Just span 6 meter. And then this is A, this is B. Loading anti-clockwise here, clockwise here. So many people, what they do is, they write anti-clockwise here and write minus WL square by 12. They write plus WL square by 12. It is height of foolishness. Height of foolishness. When you mark anti-clockwise, don't write minus. Some of them told, sir, later minus is there. That later, see, I am also using. Do not write. See, when the downward load is there, 80 kilonewton downward load. I asked the persons, okay, you take upward positive. Are you writing minus 80? No, sir. Then it looks very odd. If this looks very odd, this also looks very odd. Give respect to mathematics. Once you write anti-clockwise here, clockwise here, do not use sign. High school level common sense. Okay, leave it. I don't want to comment. This is loading. Now, project dotted line. Here, see. Now, below you write a sketch showing delta. See, A is here, B is here. So, you draw two parallel lines. Draw two parallel lines. I told you, two parallel lines. Tell me, A and B, which is upper side, which is lower side? Which is upper side? You tell me which is upper side. You should see the final position. Which is upper side? Fast. A and B. A upper side. So upper side you write here. Lower side right here. This is A to B. Now this will become your delta. Tell correctly delta. Displacement of A with respect to B or displacement of B with respect to A. One will go up by 8, other will come down by 14. You know it already. SD method I explained. 22 millimeter. This is 22 millimeter, but a millimeter we cannot use, or this is delta equal to 22 by 1000 meter. Okay. Now, elastic curve will come like this. Therefore, due to this one, see, there will be anti-clockwise moment here and also anti-clockwise here. Both of them are 6 EI delta by L square. Use a bracket. 6 EI delta by L square. Use a bracket. This is thoroughly I told you. See, if the member goes this way, it is this way. Preventing case. Sorry. Before starting indeterminate structure, in YouTube only I explained. Yes or no? In YouTube only I explained. Tell me yes or no? In YouTube only I explained. It is still there. Preparation for method, how to find FPM solve. Yes, therefore, someone will tell not clear. I will tell them leave my class. Don't come to my class. Okay, start. Now, I will calculate here. See, I will slightly sit below. You can't see me. 1 minute now. Space is there. Yes, space is there. No problem. I want to complete now. So, therefore, see, remember, clockwise positive. M bar AB equal to, see here, anti-clockwise. So, minus 30 into 6 square divided by 12 is this FPM. And this also anti-clockwise. Minus 6 into EI. Tell me numerical EI. Fast. This also 6 EI delta by L square. Tell me numerical EI. How much? What is the numerical EI? Fast. numerical EI. How much? Numerical EI. First. Yes. Last time you got trapped. Yes or no? Last time you got trapped. Earlier also so many times you got trapped. Very good. Remember? Because formula is 6 EI delta by L square, but AB member has got 1.8 EI. Don't forget it. See here. It has got 1.8 EI. EI equal to 16,000. So 6 into, without forgetting that number, 1.8 danger number. Remember, last time you got trapped. Yes or no? Last time you got trapped here. Tell me yes or no. Agree frankly, no problem. You are not losing if you agree. Yes, okay. Into 6. EI is what? EI is 16,000. 6 EI delta is 22 by 1000 divided by 6 square will give you M bar AB. Same way calculate M bar BA. See there. It is a clockwise moment. Plus 30 into 6 square divided by 12. This is once again anti-clockwise. Minus 6 into repeat. How much? 1.8 into 16,000 into 22 by 1000 divided by 6 square. Tell this answer. Tell me what is M bar AB and M bar BA. Fast. Answer. Add the two together. Tell me M bar AB. I know the answer. I can see it there. I copied that answer in a corner. You cannot see it. Minus 195.6. Correct. Minus 195.6. Other one. Correct. I got it because I can see. What I did is, when I rubbed the board, I took a photo of the SD method and what all I require for MD and Kani, I noted down in the corner of the board because it is my own calculation. Minus 15.6. Okay. Minus 15.6. Unit I am not writing because I already wrote here kilonewton meter. Don't write once again. Okay. If you are that much eager, write kilonewton meter. Not required. First of all, you already told kilonewton meter. Okay. Now, this number over. Consider BC. BC. Is the board visible fully? Is the board fully visible up to where? 1 minute now. Let me see up to where I can write. Up to here visible? Is the line I have drawn just now visible? One line I have drawn just now. If it is visible, tell me. Okay. I can move it further. This line visible means okay. I will use the board up to there. Second line, just okay, visible. Okay. Now, consider BC. When you consider BC, I told thousands of times, FPM calculation, every support considered fixed. So, B and C both are fixed. B and C both are fixed. Y means fixed end moment. Span of the member is how much? Span is 5 meter. There is a point load here of 100 kilonewton. Distance from here is 2 meter. This is 3 meter. Now, this is anti-clockwise. This is clockwise. This is W into AB square by L square. This is W into BA square by L square. This will become A. This will become B. If I explain further, it is utter waste of time. Then, below, you draw two, continue. Draw two parallel lines. Draw two parallel lines. Okay. Tell me. Consider B and C. See B and C. Don't see AB now. If you see B and C, tell me which is the lower side. Which is the lower side? If you consider B and C, this is the procedure you have to make. Permanently same procedure. Which is the lower side? If you consider B and C, which is lower side? B. Therefore, write B here, fixed. C will come here. Project it. Tell me what is delta. See now. This comes down by 14. This comes down by 4. B and C relative displacement. With respect to B, where is C? With respect to C, where is B? Last time you added. Now you should not add. Answer. High school mathematics. Delta. 10 millimeter. High school mathematics. I won't explain. 10 millimeter or 10 by 1000 meter. Okay. Elastic curve will go this way. Now see. Now, see, this is B and C. I forgot right here. A and B. Okay, Papa. A and B. Now see. Now, member goes this way. So you require clockwise. I will not explain further because these all so thoroughly explained earlier. Both are 6EI delta by L square. Bracket means applicable value. Okay, now start. Therefore, your M bar BC equal to anti-clockwise minus 100 into 2 into 3 square divided by 5 square. That is due to loading. That is anti-clockwise. This is clockwise. So plus 6 into, be careful. This member has got 2EI here. Don't forget that 2EI. Chance of getting mistake. 6 into 2 times of EI. EI is 16,000 into delta is 10 by 1000 divided by span is 5 meter. Tell the answer. And also M bar CB equal to plus clockwise there 100 into 3 into 2 square by 5 square plus once again clockwise. Repeat. 6 into 2 times of 16,000 into 10 by 1000 divided by 5 square. Tell both the answer. I can see the answer there. First answer. First answer. First answer. First answer. 148.8. No, wrong. 148.8 is wrong. I know last time some other answer is there. 148.8 is wrong. I am sure because I can see some other answer there. Last time I know the answer what I got. 148.8 is wrong. Once again do it. You added both of them without sign. One is anti-clockwise, other is clockwise. See, you made a mistake. Plus 4.8. Sorry. It is plus 4.8. Other one. Tell me other one. Okay. Plus 4.8. Other one. Other one. Correct. Other one. Other one. Little fast. Don't waste time. Plus 124.8. Correct. Plus 124.8. Okay. Done. Kilonewton meter. Okay. Now, member BC over. Consider CD. Consider CD. Be careful. Some space problem is there. I will manage here. CD. Both are fixed. Why? Because fixed end moment. UDL of 9 kN per meter. Write whatever is there. 9 kN per meter. This is C. This is D. Span is, how much span? Span is 4 meter. Anti-clockwise here, clockwise here. Both are WL square by 12. Enter here. This is the FVM due to loading. Now below, draw two, before that one, don't forget, this has got only EI. EI. Draw two parallel lines and tell fast to me, which is lower side? When I take C and D, which is the upper side? Which is upper side? Fast. Which is upper side? Upper side. the upper side. And anybody can tell me delta value before I write there? Delta value. See, C is here. See, C is here. See, D will come down. This is your delta value. Anybody can tell delta value? Ayyo, alle kaanta ide. 16 millimeter. It is 16 millimeter or 16 by 1000 meter. Okay. Now, elastic curve will come this way. Therefore, now, see, if the member goes this way, I shouted 100 times earlier. If it goes this way, anti-clockwise. Someone will tell, sir, not clear. Not clear means don't come to my class. In the earlier class, in the YouTube only it is there, how to find FEM due delta. Cried class after class. I don't know how many times I told it. Okay, start. Now, M bar CD equal to anti-clockwise minus W 9 into 4 square by 12 due to UDL. Once again anti-clockwise minus 6 into this time only EI. How much? 16,000. Only EI. 16,000 into 16 by 1000 divided by 4 square. Tell the answer. Tell the answer. M bar CD. Fast. M bar CD. I can see here. What is the answer? M bar CD. Fast answer. Minus 108. Correct. Minus 108 kilonewton meter. And M bar DC equal to plus clockwise 9 into 4 square by 12 minus 6 into same repeat. Because why? Delta term FEM is same for both ends and also same sign. Answer. This also. Now is the most important part coming. With that one, actually our class only will be over. Answer. Space problem is there. I will manage there. Minus 84. Correct. Minus 84. Okay. Now, lastly, see now. Board visible. I will put red color. Consider DE. Board visible. Tell me correctly. Little space required. Is board visible there? If I write board visible, yes, okay. Now, first to make a note, DE is overhang. I will not tell once again. When you consider overhang, theta, delta, this one, that one, support sinking, rising, dancing, rotating, moving, sleeping, weeping, no, nothing considered. Whatever loads are there, only that much. Hey, overhang, come here. Some will tell delta, delta, I'll leave it. No delta, nothing. D is fixed. E is free. Why? Where support is there fixed. This also I told you. UDL of 9 kN per meter for 2.4 meter and a point load of 12 kilonewton. And now, you have to do, support is here. This load, you should not tell crude method now. This load will try to rotate in this direction. So reacting moment will come this way. I told hundreds of times. Therefore, be careful. Your M bar DE equal to anti-clockwise minus this anti-clockwise moment equal to whatever clockwise moment comes. How much? 12 into 2.4 is due to point load plus 9 into 2.4 into 2.4 by 2. Tell the answer. Minus. Answer. Answer. Minus. Answer for this one. M bar D. No thinking, nothing. 12 into 2.4 and 9 into 2.4 into 2.4 by 2. That is the FEM for overhang. Minus 54.72. Okay. Now, tell me. Next step is go to what? Go to what? Moment distribution what? Tell me. Next step. Go to moment distribution. Fast, fast. Next, go to moment distribution. I told you, not first time you are doing. Next, go to moment distribution. Next step, go to moment distribution. No, factor. Factor, what factor? Moment distribution. What is the name I am using? Table. Moment distribution table. Okay. Now, make a note here, those who are interested. Once you go to moment distribution table, when you go there, you never bother about this delta, theta, sinking, rising, dancing, nothing. You never bother. You require what is the type of continuous beam, what are the fixed end moment, and what is distribution factor. Happily complete the table. You get the final moment, then go to star. Clear? Star in my class means SFDBMD, common for SD method, MD method, Kani's method, provided answer comes same. In my class, answer will always come same. Clear? Yes. Now, 1 minute. Imagine moment distribution is over. Okay. I will do it in the class. Don't worry. Imagine over. I will do one thing now. Imagine moment distribution is over. Tell me. Next. I am starting now. Some will tell, sir, not over. Wait for some time. I will come back. I will tell later. See, now I am finishing the remaining part of MD method. After I rub the board, I will tell, now I will come back to remaining part of MD method. Tell me. Next go to. Next go to. What method? Next go to. I will tell you why. MD table is pending. I will do it ahead. Next go to which method? Next go to Kani's method. Okay, do one thing now. I will remove the full board. See. Okay, full board removed. Okay, start once again. Master question solved by Kani's method. See, what all you have to do? Kani's method. Same note. I by L, 3 by L, everything will remain same. Same question, same EI. Instead of distribution factor, you write rotation factor. Symbol is R. Same table, only change is R equal to minus half extra. So this will become minus 3 by 14. This will become minus 4 by 14. This will become minus 32 by 92. This will 94. 32 by 94, this will become minus 15 by 94. Fully clear? Once again repeat. Don't waste time. What all I explained for MD method, again write and get rotation factor. Clear? Fast. Clear? Okay. Then, next step, calculation of FPM, kN meter, considering loading and also given support settlement. Right? Note. What note? This is for MD Kani's method. Exactly same as what you had an MD method. Therefore, from here up to here, once again copy. Clear? Once again copy. Clear or not? Full fair copy make it. Clear or not? Fast. Full copy from here to here, FPM calculation, and what all I explained, once again write. You are not losing. Some will tell, MD method is there. No. Independently, everything I told here, write once again. Good for health. So that make independent. Full from here up to there copy. Clear? Copy up to there. Okay. Then tell me, go to what? Not table, something like table where we calculate what? Rotation. Next go to table. It is not a table, some table format. Tell me, go to calculation of rotation. One word is there. Calculation of rotation. Contribution. Go to calculation of rotation contribution, that is m dash. Okay, that I will take tomorrow. Agreed? So tomorrow I will tell you Carney's method. In the title you can see Carney's method. But if someone comes tomorrow for Carney's method, oh Carney, if he comes, he will be disappointed. I will directly start. Problem I will not write. I will tell previous question where settlements are given. I will tell you, I already explained the question, already told about stiffness factor solve, already told how to find rotation factor, already told how to find FPM. I am continuing from there. Clear now? I am continuing from there. Then I will conclude by drawing SFD BMD. Okay, start. Now, over. Now I will come back to which method? Tell me. Now I will come back to which method? Fast. Now I will come back to which method? To save the time. Now this question is over. MDM, moment distribution. Okay. Do one thing now. Full I will rub now. I will come back to MD method. The question will be tomorrow. The question you can still see it. Why? Because I should explain to you what? The concept of where carryover, where releasing, that is required. Actually not required. Already told. Still, because when I take the class, what I do is, I explain it a little more. Okay, 1 minute. Even table also, very briefly I am doing. I am not doing full. I want, okay, little water I will give so that the stains are gone. Just wait for little time, no problem. I am coming back to MD method and completing the MD table now, briefly. Okay, no. Sometimes happens. Search for a good cloth, not available. Some cloth, shoky, geeky, I am not interested. Some will tell, cloth is dirty. Cloth is not dirty. It is because of the ink stained. That's why blackish. I wash this cloth almost alternate days. It is as clean as a kerchief which you carry. Only thing is color is black because of the using for this black whiteboard marker ink. Okay. Start. Now, back to MD method. Back to MD method. Make a note. Problem over. Stiffness explanation over. Distribution factor over. Then FPMs are over. Go to moment distribution table. I told you, A, fixed support, right fixed here. B, intermediate, right like this. This way. This all I told you. Don't put arrow mark here. C, also intermediate, right like this. Then very important, D is simple support. Show simple support there. Very important. Some concept is there. Mark simple, red color required. Where's the red color? Here. D is simple support. Be careful. Simple support, or right here. Simple support with overhang. It is the, this is simple support with overhang. Okay. Then mark the overhang. Okay. Then this is the distribution factor required. See here. Distribution factor A, B, C, D. Members are AB, BA, BC, CB, CD, DC, DE. Some people write ED. Again nonsense. Don't write ED. Over. Now, here we got answer 3 by 7, 4 by 7. MD method 3 by 7, 4 by 7. There you got 32 by 47 and 15 by 47. Not this. This is for Kani tomorrow. This is for Kani. Okay, then somewhere here. These are the members. Right here. Members. Enter the FPMs. FPM I rubbed out, but I can see there. Answer is minus 195.6 minus 15.6 plus 4.8 plus 124.8 minus 108 minus 84 and minus 54.72. Remember, at the overhanging support, I told you distribution pattern need not be calculated. Inside is 1, outside is 0. Okay, tell me. First step is release what? Unbalanced moment. If it is simple support, see, if overhang is not there, you call release moment at D. Now it is called release unbalanced moment at D. How? You add the two value. Tell the answer. See, if the overhang is not there also, only one value is there, minus 84. Put plus 84. But here, two sides are there. Usually, this will come plus and minus. But this time, because of settlement, both are minus. Use your calculator. Tell me. Add the two values. Answer. Add the two values. Answer. You add the two values. Whatever is there, add it. Tell me. Usually one comes plus and minus, but this time due to settlement all, both are minus. Minus or plus. Add both the values. Minus 138.72. Change the sign. Plus 138.72 into 1. Plus 138.72 to inner side. Nothing that side or 0. Then immediately half carry over here. Answer. This is intermediate support. Carry over is there. Half carry over. If the overhang is not there, minus 84 plus 84 carry over 42. But overhang is there. Add the two values, then change the sign and write it for the inner side. Then even 1 and 0 also not required. Answer. 69.36. 69.36 plus 69.36. Okay, now that's all. By chance, if they give simple support here, you release this one, carry over half here. Okay, now immediately put one double line. Double line indicates what? Indicates, I sometimes call initial FPMs, initial values, or you can tell modified FPM. Modified FPM. Okay, then see here. It is minus 195.6 minus 15.6 plus 4.8 plus 124.8. This will tell me minus 108 plus 69.36. Answer. Minus 108 plus 69.36. Answer. Fast. Minus 108 plus 69.36. Don't give wrong value. Do not give wrong value. Minus 108 plus 69.36 minus 38.64. Okay. 38.64 here plus 54.72 minus 54.72. Okay. Now, most important, this I told to avoid confusion. When you now see, since you added up to here, now all these values gets cancelled. Don't cancel actually. Don't cancel. All cancelled. Start fresh from here. Okay. Don't cancel. Now important. When you carry over by mistake, you may carry over. This is simple support with overhang. Therefore, I told block. Blocked means no entry. Like police will do. No entry. Don't come here. Road blocked. No carry over this way. Clear or not? Told 100 times. Clear or not? No more carry. Blocked D. Okay, thank you. Comment only came. Blocked. Because comment is given by someone who is my regular students. Okay, start. Now, enjoy the table. Can you enjoy the table? Can you enjoy the table now? Can you enjoy the table? If you can enjoy the table, I will conclude. Because this I cannot explain in the YouTube class here. This I thoroughly explain for the batch. Those who are public, general public, you should know what to do. Briefly I will tell. Okay, start. I will do one thing. I will do fast now. See the speed. What I am doing. Some statements you have to write. You refer to the first question and write. Okay, start. Come here. add the two values. Whatever you get, change the sign into this number here, balanced. Add the two values. Whatever you get, change the sign into the factors here, right? Remember, this class is meant for my regular group. This is told thousands of times for them. Any newcomer, you should know this one. Some students will tell, sir, this we know, sir. We have confusion about these things. Yes, then it is useful. Sir, the delta is confusion. Yes, I cleared it. End correction, I cleared it. Table people are knowing. Then immediately you should write there some statement. Half carry over here, half carry over here, half carry over here, half. Oh, no. See, never carry over here. This is blocked. Okay. Then once again come back here. Add the two values. What two values? Only one value is there. Change the sign into factors. Write once again here. Add the two values. Change the sign. Multiply. Half carry over here. Half carry over here. Half carry over here. No carry over. That way, continue till you reach least count of 0.01. Yes or no? Because in our class, least count is 0.01. Till you reach 0.01, continue. Everywhere it should reach 0.01. Clear now? Tell me. Clear. Okay. Then what you do? Finally, add the values. Okay. Finally, add and get the moments. Those who are in the group, right now do it. And in the comment box, in the group, you send the message to me that got the final answer. Agreed? Those who are in the group, after the class is over, you complete the table. Or do one thing. You solve completely, then send a comment there to me, that, or not comment, message there, that yes, we got the answer. Agreed? Okay. Now, shall I add and get the final values? Shall I add and get the final values? Fast. I got a super calculator with me, where even though table is not done, my super calculator will consider it. Shall I add and get now? Yes. Okay. This is the super calculator. See, empty inside. But I should show it to the table. Yes. Over. Some will tell, looking there. Where you are looking, sir? Minus 186.07 plus 3.45 minus 3. This shows the confidence. Final moment, go to star. Tell me, is the solution fully clear? Those who are regular, fully clear? Okay. Tell me, do you think, is it the super calculator? Tell me. Is it super calculator? Tell me. Is it super calculator? Then I can sell it for lakhs of rupees. Is it super calculator? Fast. You are not answering. Is it a super calculator? Any parvailla. But no, don't tell that way. Then how I got the answer? Anybody can tell how I wrote the answer? Because this question is already solved by me in the last class. By which method? Don't praise me. I am not asking. This question already we solved by which method? Tell me. We already solved last class by. One class you wasted actually. This question already we got solved by which method? Already solved by which method? Question already solved by SDM. There you got the same answer. Yes or no? There you got the same answer. Why same answer? I noted down the answer by the photograph. Last time when I rubbed the board, I noted down the answer in a corner. And I have infinite percent confidence in my class. SD method, MD method, or Kani's method, or any method. Let it be stiffness matrix, flexibility matrix, or some kind column energy method, not applicable here, constant deformation method, strain energy method, any method you solve, answer will be same. Otherwise, I told you, I am going to stop the teaching. Okay. Now, that's all. So, tomorrow when you come to the class, I will start directly Kani's method, question I won't write, factor I won't tell, FPM I won't tell. I will directly start rotation, contribution, and close the method and draw SFD-BMD. Clear? I will directly start Kani's method. I will tell last. No, I will start Kani's method and tell what? Yesterday only we reached up to here in Kani's method. Further continuation, I will do Kani's method. Okay. Nodi. After all the explanation, only 8:47. I can do today only. But feeling tired because of non-stop talking. Today only I can do it. But SFD-BMD pending. Shall I do tomorrow? No problem. Today only okay. I got still 15 minutes more. 12 minutes. But feeling tired, so tomorrow I will take it. Agree? No problem. So tomorrow I will continue, including SFD-BMD. Okay, thank you. Now, actually, those who already know Kani's method, you can compete yourself only, correct? But why I am doing is for public, let them see how is the Kani's method table looks like once. Okay, thank you.